All right, kids, here we go, 10-9. This should be a quick, fast lesson, though a lot of interesting problems that are waiting for us in the last chapter 10 section. Circumference and arc length. You're going to get a lot of problems that kind of revolve, excuse the pun, around this. And you may say, what does that have to do with me? Why do I have to find these distances? Well, most of us have at some point or another ridden on a bike, and we typically have a chain and two things. You may have run around a track at some point in your life. Somebody, not you, has marked off. And you notice some of them are even staggered. And that's because somebody has measured the distance. And so this distance is the same as this distance. So that's why the finish lines are slightly, or actually the start lines. Finish line is always the same, but the starts are always staggered, if you will. All right. Finally, maybe, just maybe someday, you too will travel to space. Maybe you'll jump in a little capsule sitting on top of a rocket. And this is the path that you travel when you head off to space. Going around the planet's a really good idea because it's kind of like a slingshot, gravitational force. See your science teacher for more information on that. Whips you around, gives you additional speed, and allows you to get there faster. And then we do the same on the return. Yeah? All right. You might have seen a CD or two in your life. If you could zoom into that CD microscopically, yeah, there are these little sectors. And the outer sectors have longer lengths. The inner ones have shorter. Yeah? Because they're all kind of part of an arc that's revolving around a circle. And the further you go out, those arcs increase. So that's how you store information on a disk. And that's why disks aren't all that popular anymore. Too much spinning. All right. We must keep in mind the arc length is a percent times the circumference. Yeah? aka something over 360 times 2 pi r, or pi times diameter. All sorts of ways to think about that. But know that that is kind of be your bread and butter. It's kind of how you get you out of sticky scenarios. So here we have a 40-degree angle, and I've got a radius of 3. And so what is that arc length there? Heck, we'll do the whole perimeter. Remember we did a problem like that on the quiz. It wasn't quite this complex. So the first thing I need to do is, well, my radius is 3. So let's put 3's down there on my radiuses. So I know I have 6 plus. Now I got this piece. Well, that's the arc length. And so that's a portion. How much of a portion? 40 over 360. Is my raw number. I'll work with that, change it up a little bit, times 2 pi r, which would be, I think, 6 pi, right? 2 times 3 is 6. All right, so 40 over 360, well, that's the same as 4 over 36, which is the same as 1 over 9. So 1 over 9 times 6 pi is what we have to do. So 6 plus 6/9 pi, aka 6 plus 2/3 pi. Boom. There is my distance. Some units, we don't know necessarily what we're measuring the 3 in here, but the distance all the way around that slice would be 6 plus 2/3 pi. Find the circle's circumference is 64. Find the radius of the circle. So we're working backwards here. 64 pi is the circumference. So 64 pi is equal to 2 pi r. So if I divide by pi, that cancels the pi's. If I divide by, pi should have gone. If I divide by 2, I get 32. So there's my radius, 32 inches. Then I want to find the length of the arc of a circle with the 12 centimeter radius and a 105 arc.
Kind of important here.
Mr. Larson!
I'm in the middle of a video, which you are now featured in.
Oh, fun!
That is so interesting.
Okay, we'll walk
Two
away.
other teachers.
Yep, okay,
I'll see you in a
walk
bit.
away. Have
All
fun!
right, good luck.
Thank you. All right, hopefully you recognize those two names. We got to find the length of the arc, and we've got 12, and we've got 105 degrees. Hi, come on in. I'm making a little video here. So I'll be done in just a moment here. 24 pi is the distance around that circle. Yeah. Times 105 over 360. So I'm going to reduce 105 over 360. Oh, I divide them both by 5. Let's see, 24 pi times 21, 72. I think they're both going to divide by 3 again. So 24 pi times 7, and 3 goes into that, 24. So the 24s cancel. Haha, 7 pi is my final answer. So the distance around the length of this arc is 7 pi units. One quick last example. I'm going to jump to part B here, skip part A. Well, let's do it. We got to do both. So we're rotating 1,000 times. How far does the bicycle travel? Well, first thing you need to know is what's the circumference of this circle. So its diameter is 70, so 70 pi would be once, right? And then if I want to do that 1,000 times, obviously I think you can then see you would take 1,000 times 70 pi, which would be 7,000 pi. And again, we put centimeters here. If you wanted to round that number off, you certainly could. If I was going to ask, how many revolutions in 50 meters, first of all, notice we got meters and centimeters. So the first thing I would do is take 1,500. That's 100 centimeters in a meter. So 1,500 centimeters divided by, and again, 70 pi is the distance around one circle from the previous problem. My good old calculator friend here. It doesn't make sense to leave this in an exact answer. Wait, I need parentheses around my denominator. 70 pi, parentheses close. Okay, so I get 6.8 revolutions. 8.20 revolutions. Almost 7. All right. Best of luck as you do your problems, whether they be simple ones like the ones we just did, or more complex ones like what is the distance around the track, right? You got to add up all those pieces. There's different problems like that. Best of luck.